kiss for you.
Hello. So this is going to be kind of a little bit of a different video. As you can see, it's going to be your ultimate guide to computer basics. Now, basically what this means is I'm going to be trying to go over everything I possibly can about computers and the basics of it and kind of get everyone up to speed with sort of general guidelines and sort of structures that revolve themselves around computing. So I'm not going to list everything I'm going to be doing. There should be timestamps either spaced out in the video or in the description or both. So let's get started with, I guess, the first thing. Hopefully, the first thing you really want to talk about is types of computers. So we'll start off with the basics and then get into more in-depth stuff. You can just go to whatever section you want to learn about. So types of computers. There is a couple different types of computers that you should be aware of. There's four main types. We have laptops, portable computers. We have desktops, which are typically seen as tower computers. We have enterprise and or server computers, and we have ARM, or what we're going to be calling mobile computers. So the four types of computers: mobile/ARM, laptop, desktop, and enterprise, and they respectively make up sort of the generation 4 of computers. Now that's important because those are different types, and the types mean different things. Laptops are, as you know, thin, lighter than desktops, portable, have a battery inside of them. Desktops are bigger, require an outlet for power, usually stronger, needed for that kind of thing. Enterprise and or server are typically located inside of server racks and are used for large companies to store a bunch of data and sort of manage many different machines all at once, either through a server like you can see here, or through the cloud. So servers usually have many computers in sort of sandwich shaped versus typical desktops or laptops, which won't look like that. And then there's ARM, which is a little bit different. ARM is the basis. We'll get into that in a moment. But basically anything mobile, so phone, for instance, any phones we have here use ARM chips, certain laptops and stuff. Just because I'm saying ARM doesn't necessarily mean mobile, but I'm trying to equate the two. Typically, ARM processors have been in mobile devices like watches and phones and tablets and stuff, but now they're making their way into laptops with the new Apple M1. So the new Apple 13 has their M1 chips, and their new iMacs and stuff also have their stuff, and then Microsoft also has their Surface laptop things that have been categorically mobile for a while there. This one is an i7, but there's other ones that are based off of mobile processing, ARM processing. So those are the four types of computers you should be aware of. And let's go on to architecture. So as I was kind of hinting at before, the types of computers, there's multiple different architectures, one of them being ARM, that computers can kind of go at. And there's really two or three main ones, depending on how you look at it. There's mobile, ARM, and x86. So typical laptops and desktops and enterprise, for that matter, typical anything can have x86 processing except phones. x86 is a development architecture that effectively allows general communication, and it was made by Intel for general communication on different laptops and different hardware levels, originally with Windows, but also in Mac. In a lot of cases, everything is built on x86 architecture. So as a good example, exe files or executable or DMG, Mac's version of an executable file, are all based on x86 architecture. Let's bring up File Explorer here. That's about as good as I'm going to be able to get that. And if we go to my PC and Windows, you can see here the program x86 files are what you'll see. Program files and x86 files, you go into that and it has all your programs downloaded: Audacity, Apple software, Adobe, Dropbox, games, Google, HP, Java, all your Microsoft things, Steam, anything from Windows is based on x86 industry register files, that kind of stuff, are all based off of x86 architecture, and that's what you'll see there. If we go on to something like the M1 chip that Apple has, the M1 chip isn't based off of x86 architecture, Intel based. It's based off of ARM, which is a company. So basically ARM is a company and a process. So it's an architecture, as you can see here. It's basically architectures are effectively instructions that processors need to run on in order to function. So the M1 chip and other Snapdragon chips and stuff, anything that runs on ARM architecture is basically just a set of computing instructions that's found on that chip that's different. And you may say, okay, well, if x86 has been around for a long time, what's the point of having ARM, this relatively new system structure, be there, and you need to sort of redesign a bunch of things for it? Because different architectures are inherently different computers, right? If I try x86 files or use x86 things like exe or DMG or any of that stuff on an ARM chip or an ARM computer like the Microsoft Surface or the new MacBooks, it won't work natively. Basically meaning if I try to pure x86 architectured stuff on that, it will not work. And the reason it won't work, we'll get into in a moment, but just that it won't work purely. So there's two architectures, ARM, x86. They both are used for different things. They both have their advantages and disadvantages. x86 is used on most things today. It is not used on phones. Things that use ARM are phones, tablets, and depending on the laptop, some laptops. Now, not most laptops. Typically a laptop that has Intel or AMD or any processor attached to it is x86 just by default. Anything that isn't, let's see if I can get, so the M1 Apple ones, I forget what the Surface laptop is, but let's see if I can find an example. Yes, this is called the Microsoft SQ2. That is not an Intel, AMD, or other. It is their own proprietary chip, which isn't necessarily a problem. It's just built on a different architecture, which is ARM. So yeah, two architectures, ARM, x86, they're used for different things. Be aware of that. I spent too long talking about that, so let's go on to the next thing. So there's multiple types of computers, different architectures. Most things are x86. We're slowly transitioning to ARM because it ends up having a couple of advantages. But yeah, so now let's talk about the difference in the types of computers. So desktops, as I said before, are towers. They're big. They require an outlet to be powering them. Voltage power. They're usually stronger. They're usually cheaper. They're usually used for more intensive workloads where you need something that's not just a carry around laptop. You need something that's power. They typically are upgradable. They typically have better cooling, and they typically are heavier, just bigger machines. Not all the time, but a lot of the time they end up being bigger and heavier. So a couple of those words might be a little odd. Upgradable, basically meaning the components inside of a computer. A computer is just made up of components or whatever. Your RAM, your storage, your CPU processing, your GPU, that kind of stuff. Things are upgradable, meaning you can take that out and put in a new one, connect up the wires, and everything works fine. That's just kind of on that basis. I would show you mine computer. I actually probably can pop up a video of that, but basically desktops are widely upgradable. Let's see. So the fan cords, that's kind of messy, but you can upgrade them, right? Laptops you can't. If you look at a typical laptop, if you look at a typical MacBook Pro, so at the insides of a MacBook Pro, you'll see that it's all completely soldered. God, this thing, there's just a lot of stuff to talk about. So soldered means things are adhered to the board and cannot be removed. So unlike a desktop where we saw before, where you can easily remove things by undoing a couple of wires. Things are soldered, meaning they can't be removed from the motherboard. They're effectively glued in place to the main component motherboard, main board that you're working with, and so you can't take things out of it and rearrange it and stuff. A lot of things, a lot of phones, a lot of laptops have soldered components that you can't upgrade. Some do, some allow upgradability, most at this point don't. So that's important to note. Yep, there's that, and be plugged in always. Laptops, phones are obviously not upgradable as well. They have similar design in that regard. Let's look at the iPhone 12 inside, just as a quick example. This is the iPhone 12 inside. Once it loads, this is a better image of it. So we basically have the battery, which is this L-shaped thing, a bunch of components. As you can see from the components, if you can see closely inside, you don't see any components, right? You're not seeing a coil, you're not seeing anything. It's all under this heavy metal, and that's because you have to unplug all the little connectors here, unscrew all the little screws around here to eventually get to the actual components, which means the components are not upgradable. They're, you know, stuck in place because it's a phone. It kind of has to be. In a lot of regards, needs to be that rigidness because it's going to be moving around a lot. So that's mainly the difference between desktops and laptops and their upgradability paths and the ARM stuff. Desktops, again, I've already mentioned what they're used for: big, large projects. So next thing I want to talk about is I/O. So logically, you have these desktops, you have these laptops and stuff, and the main way you're going to be interfacing with them is through keyboards and cameras and trackpads or mice and headphones, right? All those things used to generally interact with your computer, speakers, that kind of stuff, are considered input and output devices, or I/O. So input and output devices can be anything, as I've said before: keyboards, cameras, headphones, that kind of stuff. And what I/O your computer has is quite important, right? USB ports. Keyboards, for instance, external keyboards. So if you're buying a laptop, they have a keyboard built in, right? It's the thing you're typing on. But for instance, desktops or other like iPads and tablets and stuff, if you want to use an external keyboard, if it's a wired one, which means physically connected in, you need a USB port. Those are pretty common, you know, standard USB-A port. We'll get to the different types in a minute, but this is a standard USB-A port, right? USB-A, you plug it in, it activates on whatever computer you have, right? And we're all good. Other types of I/O include, I guess I talked about the types of USB here. So there's a couple types of USB as the main form of I/O that people typically use to add things like, again, keyboard and stuff. USB-A typically used for keyboards, microphones, like the one I'm using now, displays, that kind of stuff. USB-A is used for that. USB-B, which is less common. USB Type B is not micro. USB Type B is this weird looking connector right here. USB-B is used for older devices like microphone is right here. Display, so my Dell display, I did a review, you can go check that out. My Dell display has a optional connection to effectively power the USB ports on the device, and you have a separate cable that's a USB-A, the normal brick one, into a computer, and then a USB Type B connector. Actually, that's mini. Sorry about that. This is a USB Type B connector. Yeah, this is USB-B. USB-B, it can be used for old devices like microphones, but it's typically used for things like displays or anything that just needs more power than USB-A can handle. USB-B for the display allows it to power these other USB ports on the device here, and that connects to the computer. Mini, which is this, which is even less common than USB-B, is used for things like microphones. If you have the TI-80 whatever calculator, TI-84 plus CE calculator, that charges through mini USB. This thing right here charges through mini USB, and it has a green light. Microphones, other audio equipment, other headphone equipment can potentially use micro. People don't really use micro anymore. It's, again, normally older devices, ones that aren't as thought about, like calculators and stuff, tend to use micro. So that's micro, that's USB-B, and then USB-C, which, and then micro, I guess. So we have mini, USB-B, USB-A is this one, micro is this one. Micro is used for things like wired mice, headphones a lot of the time, older headphones. Now we're moving more so the modern connector, but headphones, mice, the PlayStation 4 controller, the old Xbox One controller all use micro for their connection. It's a small connector. Phones used a while there. A lot of Android phones were using micro as well. So it's still being used in some devices, but we're kind of moving away from that, luckily, into more modern connectors. But micro is still used in some capacities when it's really needed. It's a small connector. It breaks pretty frequently, and it's not very quick. So that's why we were going to more modern standards, at least at this point. So the last USB we're going to be talking about is USB-C. It's pretty common. Now this is a USB-C, USB-C, but basically USB-C is the universal connector. So unlike the other forms of connectors, which are basically just used for power, USB-C is used for many things. It's used to charge devices, power. It's used for external display. It can be used, for instance, on a laptop. I have a cable right here. That's a HDMI to USB-C. I plug the HDMI into my display that transmits video, and then I plug the USB-C into my MacBook to project that screen onto my display, and it kind of acts like, to allow external displays, kind of like a video transfer. So it can transfer power, video, external GPU, external graphics card housing. You can plug that in, give your computer more power. Just a lot of things USB-C can do as more of a universal connector. It's not limited like USB-A is to just power delivery. It can deliver video and audio and that kind of thing. So that's mostly where devices are moving. Headphones and stuff are moving to USB-C. And so, yeah, that's mainly the USB-C connector. Other types of input-output include HDMI and VGA. So HDMI is the connector that's typically used for connecting video in display. As I said before, you can connect it to your display out into a laptop or desktop or some other type of device that supports the system, and that's for video. That's a typical video. There's different versions or whatever of HDMI. Basically, all you need to know is the higher number is better, but there's whole compatibility questions. So when in doubt, use HDMI 2.0 is always the best to use. Most of the time it's not going to say, just assume it's HDMI 2.0 when in doubt, because that works on basically everything around here, and it's a good sort of speed, right? It's a good enough delivery source. But there is also HDMI 2.1. Basically, if you have a new PS5, Xbox Series X, or a new TV, like an expensive new TV, HDMI 2.1 could be an option, and basically that just allows you to have higher resolution, higher frame rates. That's a whole nother topic. It keeps going on. Basically, HDMI 2.0 allows you to have 4K, 120 Hz, 120 FPS output versus HDMI 2.0, which only allows you to have 4K 60. So HDMI 2.1 allows up to 8K, whatever, 60, and 4K 120, and HDMI 2.0 only allows up to 4K 60. I'm pretty sure it doesn't extend that 4K 120. So just keep that in mind. Again, you'll only see this on you'll only see the input of this on expensive TVs, and you'll see the output kind of cable on things like new game consoles. So that's really, you don't have to worry about that. Displays, like external displays, monitors and stuff, haven't really gotten to the point where they're accepting HDMI 2.1 at a good enough scale for anyone to really worry about it. Last but not least, mini display and VGA. So VGA is this disgusting thing, and it was used for a while in older machines in the early 2000s as the main form instead of HDMI. So it's kind of like been replaced by HDMI. It was this connector, you plug it in. This is the thing you plug it into, and you screw in the little screws here, and it plugs into this thing, and it delivers signal, right? Similar to how HDMI did. You'd see these a lot on old CRT TVs, monitors, studio, theater, big TVs, and old computers. You'd see this a lot. So it's not really used anymore. It's been replaced by HDMI. Okay, the last connector is the DisplayPort. So DisplayPort has a couple of uses. It is another form of video input and display. And effectively, what DisplayPort does is it's a better version of HDMI. So there's HDMI 2.0, as we said, 2.1. This DisplayPort effectively acts as a HDMI 2.1 sort of input without all the compatibility problems. So basically, I have this cable that I was talking about before. I have two cables, actually. One that was the HDMI to USB-C one that I was using to connect my monitor to my HP Omen computer there. But I have this other one that's for connecting my Mac, and in order to get 144 hertz on that one at 2K resolution, which is what my monitor is at, I need a DisplayPort. And DisplayPort is more compatible than the HDMI 2.1 standard, because just because it has an HDMI port doesn't mean it's HDMI 2.1 compatible. So DisplayPort is another option that can be used if you want higher frame rate and stuff. So yeah, it's pretty common on monitors, TVs, graphics cards for computers also have DisplayPort. Depends if it's out or not, but won't worry about that now. Yeah, and you basically just connect it, and boom, you got your video signal out to whatever you're looking for. Okay, that was... Am I recording? Oh, thank God. Oh my God, it's already 23 minutes long. Okay, this is going to be like an hour and a half video at this rate. Yeah, that's basically what that's for. SD card readers, headphone jacks, basically, just plug it in, whatever. SD card readers, so you probably know what that is. Camera, insert an SD card. It's a form of storage, effectively, which we'll get to in a moment. It's not really an input device, although I thought I should mention it. For cameras and stuff, for instance, you take a picture on like an actual camera, and the SD card is the thing that, yeah, these things. It's the thing that you're able to plug into anything that has that port on it. So desktops, some laptops, some adapters and stuff. And basically it's just another form of storage. So, all right, we're finally done talking about I/O, and we'll talk about components now. So, as I said before, the PCs, the desktop PCs, and the laptops, and to some extent the ARM-based mobile devices have a bunch of components to them, and I listed them off, and you might have been confused about a couple of them, so we'll just go through those. So I'm not sure what the first I mentioned, but we'll start with whatever the base is, which is the motherboard. So a typical motherboard is effectively just the central thing that all your components kind of click into on a device. On a desktop, it's typically laid vertically. On a laptop, it's typically laid horizontally. On a phone, it's typically laid vertically, or depending on the orientation of the phone. Typical modern day one of these kind of looks like, wow, that's small. Kind of looks like, you find a good one, yeah, like this. You can't look at that. This thing, okay. So this is the best, I guess, example. It's kind of weird. This is an Asus one. It's effectively what you plug all your stuff into. So it may look a little complicated. It's just a bunch of garbage on the side here. So effectively, you have, this is a top-down view, but effectively, boom, it's labeled. Okay, great. Let's open you up. So this is, that's useless. Sorry, give me a minute, open image in new tab. There we go. So this is an older motherboard. Let's see what is this? This is a mini, okay, it's literally nothing, whatever. This is an older version, but it still should get the point across. you have your, okay, yeah, I could use this. So this is an VG, so basically it's kind of laid out in where your stuff is going to go. So anytime you see like on a laptop, on a desktop or whatever, you see input, right? You see your USB, your headphone jack, your card readers, that kind of stuff. That's a part of the motherboard that's physically attached to the motherboard and kind of lined up with whatever holes in the case there are. So in this example, we have VGA is right here. DC is your power. So motherboards need power. They typically have pin connectors. You plug it in and it attaches to some other thing in the back. You then plug that in the desktop's case, into a wall outlet, and it gives that power. You have your ports. Typically, they're all contained in one side. In this case, you have VGA, you have HDMI and DisplayPort, you have USB ports, you have Ethernet. It's technically an input device. Basically, it's just a way to better transmit Wi-Fi. So you have your LAN ports, you have your input-output for headphone jack and speaker microphone stuff, and then you have your microphone port. You have that's basically and then HDMI, that kind of stuff. On the center, so if we're looking at a top-down view, typically under this fan would be where you put the CPU. So if we go back to like one of these examples, what's a good one that has the CPU? Yeah, this is a good one. So, whoops, I didn't mean to save you. Open image, new tab, there you go. So this is a better example. So under this fan would typically be something like this, which is a socket. They all have names. They're all compatible with different chip manufacturers and stuff. It's a whole thing. But what you basically need to know is you have this, which is where your chip goes, your CPU. We'll get into that in a moment. Central processing unit. That goes there. You have your socket, a heatsink, effectively a giant metal-looking turbine thing that you plop on top of your CPU, you bolt it down with screws, you put some paste on that thing, and you hope that it all spreads out. You slap a fan on top of that, and then it sucks all the air out of your CPU, because those things generate heat because they're on and they get powered, so they generate heat. Put the heat sink on, it spreads all the heat. Let's see if I can get a picture of a heat sink. So effectively, this is a typically what it looks like. So you'll have the CPU, this part right here is similar to the socket right here. Put CPU in, you have your heat sink, it spreads out all the heat when it's being generated, and you have this plastic fan, it spins, it sucks up all that heat, and it releases it. That's why your computer has a bunch of fans. That's effectively what's called cooling, is when you have your fan and it's sucking all the air from the CPU and it's dispersing it. That's cooling. Same thing with the GPU. And that's kind of this system is called heatsink, a fan. You have your CPU socket there. You then have your Wi-Fi. So anytime you're connecting to Wi-Fi, that's a specific card on the motherboard, pre-installed into the motherboard, that's allowing you to do that. So there's space for that. There is a space for PCI, which you have to, I have like a note thing I'm looking at here. Yeah, I can talk about that now. So PCI is effectively, if you're looking at a motherboard and you're trying to figure out, okay, what am I looking at? Wi-Fi card, slot for the GPU, a different Wi-Fi card. DIMM slots are effectively the same thing as PCIe slots. DIMM slots are for your main memory. So there's a bunch of different types of memory. Mainly if we're looking at components, there's RAM, your hard drive, and or your solid state drive. So that's a component of a machine, is the storage. You're storing things. Where does that go? So your RAM goes in the DIMM slots, as you can see here. These things are DIMM slots, SODIMM slots. Interchangeable, not interchangeable, they mean different things, but for the purpose of this, they are interchangeable. It's where you put your RAM, it's where you put your I'm gonna do stuff now memory. So there's your storage, which is effectively long-term, I'll wait on it memory. Your SSD, which is long-term, do it faster, I'll wait on it memory. And then your RAM, which is do it now memory. Your RAM is effectively the thing that when you open a web page, like when I have all these tabs open now, it's stored in, doesn't capture my task manager, why not? No, okay, it doesn't capture task manager, that's annoying. I'm sure it's fine. So basically we have task manager, Yeah, there we go. Okay. So Task Manager, as you can see, a couple programs running here, and you can see memory, right? It's taking up memory. If I go to the Performance tab, memory is my RAM. I have 16 gigs of it right now. 8 of it, or 7.4 of it are being used. 8.5 is available. Basically, that means half my RAM is being used, which is okay. That effectively means stuff like Audacity, what I'm recording the sound with, OBS, Edge, all that stuff is using memory, right? It's actively using that memory. That's the RAM, and that's what you're fitting into the RAM slot. So you have PCI, which is DIMM and SODIMM, or effectively where your RAM can go. It's not needed, but I mean, it is needed, but that's where you go. And you can tell it's SODIMM or DIMM because of these little tabs on the side. It can be whatever color, but it's effectively the tabs. Pop them open, put in RAM, clip them back in. PCI is effectively where your connections are. For instance, another Wi-Fi card, you'll put it in here. A graphics card, a thing that is effectively your power workhorse for any video editing or photo editing or any of that stuff, can be done through the GPU, any gaming and stuff, right? GPU, plug it in here. They look different in every system, but effectively your PCI slots are what allows that card or that external thing you put into to connect with the motherboard and then connect with everything else. These slots are important. So that's effectively what a motherboard is and all the components that relate to it. You got your PCIe. Motherboards have different features. There's a lot that can go into it, but that's all you need to know for that one. So the next thing is we're going to talk about CPU, GPU, basics of that. Your CPU is a little square. The basis for the CPU is judged on nanometers, which are measurement in transistors. So effectively, let's just look at like a Ryzen CPU here. Yeah, so this is what it looks like. It's based on, I don't even know where we're at, like 7 nanometer, right? I think we're at. So here's a little square. It looks like that when you take it out of the box. The 7 nanometer has to do with the distance between transistors. Effectively, smaller nanometers equal more transistors equal better power. That's all you need to know for that. And better power is typically more expensive, but you know, whatever. Look like that. These are the pins. These aren't the transistors. These are the pins. You put the pins on the thing, on the CPU thing on the motherboard, and boom, you got your CPU ready to go. GPU is also measured in nanometers. Not as important though. I'm not sure what the current one is. It's like 15 nanometers or whatever. Similar thing, similar concept. You plug it in, and you're good to go. So heatsink, we already talked about that. Thermal paste is kind of important. So when we were talking about that, we were talking about the heatsink as before. There's thermal paste on the CPU. So let's just take a look at this. So there's the CPU socket. You put the CPU I showed you in before into that socket. You put thermal paste. Effectively, it's just a thing to allow it to cool. You put the heatsink on. You bolt the heatsink down, however it says to be bolted. You put a fan on. There you go. It's thermal paste. It's just a paste for the CPU. I've already talked about the RAM, the memory, DDR types. Okay, so RAM and memory, as we said before, is effectively your do-it-now storage. And there's a couple of variables with your do-it-now storage. Your speed of the storage, your size of the storage, how compatible is it with your motherboard, and your type of storage. So if I just look at RAM, 16 gigs, so what we'll explain for this is DDR type is effectively the generation that your RAM is on. Higher generation RAM, better at doing things now RAM. Your speed is how fast is that RAM doing things. You want high speeds. How fast is it going? Size, you want a bigger size. 16 gigs is a big size. 32 gigs is a bigger size. Things are bigger, usually meaning it's better. So we're on DDR like 6 or something now, kind of. There's like a couple of different variables. So the general DDR we're at is DDR4. In desktops and laptops, we're on DDR4. Certain specialty products like the Xbox Series X and the PS5 use GDDR6. Don't tell me what happened to 5. We kind of just ignored 5. I think we're on 6 now. But basically, that's a special type, and it's stupid fast RAM. It's like RAM that's specially connected with your storage to be better at RAM, and it's crazy. And that's effectively what that is it's RAM that's connected to your SSD and your main storage or whatever, and can do things really quickly. That's effectively what that GDDR or whatever means. So again, speeds, you're typically looking at modern RAM is like 3200 megahertz. It's just a metric or whatever. RAM, obviously prices are fluctuating. Right now really sucks. But yeah, 3200, that's typical. 2666 is actually what I'm running because it's a little bit of older machine. Still DDR4. You can check actually your speed, 2400. So that's an interesting point that I'll talk about, is that my RAM is actually 2666, I believe, but my motherboard is supporting it at 2400. So even if your RAM says 3200 and you buy 3200, you put it in your computer, it might not necessarily always work that way because your motherboard might not support the correct amount or speed of your RAM, and so it will downscale it to whatever it's at. You can fix that by either buying a new motherboard. It might be something in the BIOS that's messed up. But yeah, that's effectively what that is. So that's your RAM, that's your size. Bigger is better. Speed, bigger is usually better unless your motherboard can't support it. The types, fourth one's what you want. DDR4 for desktops, laptops, that kind of stuff. Storage types, as I said before, RAM is a type of storage. It's your do-it-now storage. Hard drives are your slower storage. They're physical disks. So hard drives are physical disks. Spinny disks look like this. They're stacks, they spin, they locate data that way. They're slower, much slower than SSDs, but the benefit is they are big. They can store terabytes and terabytes of data, which is a lot of data. Megabytes, small, gigabytes, bigger, terabytes, large, petabytes, even bigger. So yeah, that's their hard drive. The SSD effectively is a little bit different. It moves bits around. I don't have time to get into the bit stuff. If I literally explained everything, we'd be here for like 6 hours. But effectively, this stick-looking thing is an SSD mostly. So we'll get into that. Basically, moves bits around. It's much, much quicker than a hard drive. Can access data quicker than a hard drive. That's why it's speedier, because it can access data quicker. Typically smaller, right? Typically 256 gig, 512 gig, 1 terabyte. Can't get to the 4 terabytes or whatever that we have currently. Yeah. Hard drives come in typically one format, which is block, big block thing, this big thing right here, spinning disk. Typically the only variation is the size, 3.5, 4.5 inch bayed, this is called a bayed components, right? SSDs come in 2 varieties. There's SATA, which is this thing right here, this kind of box SATA thing, 2.5 inch, and M.2, which is this tiny little stick. SATAs are effectively installed similarly to how hard drives are installed. They're installed connected pin, that kind of stuff. M.2s are installed a little differently. On certain motherboards, there's M.2 slots. Effectively, this little tiny thing right here connects into a slot on the computer, and you basically slide in, put the screw on the other side, click it into place, and boom, you're all set. It's not like a big thing you have to connect into it. It's a relatively smaller thing. M.2s are even more expensive. Luckily, they've been around long enough that they're starting to get a little bit cheaper. So that's all you gotta know for that. Power supplies, effectively, everything needs power. Power supplies, if you're not aware of like what they typically look like, power supply, go to images. This is what they typically look like. Big connector, they're usually internal, sometimes they're external. If you want a good example of an external power supply, you can look at the 24-inch iMac. Probably not gonna be able to find it, but the brick. Laptops tend to have external power supplies. So you know, like the Apple big charging adapter. I wonder if that's, yeah, the Apple like big adapter thing. Any of these are technically this stuff, right? The 96 watt USB-C power thing, that's external power supply. That's relatively small in comparison to 850 watts. So those 96 is 850, right? And mine here, my HP has 550, mainly because it's a 1080. It doesn't need to suck up as much power. More recent graphics cards are typically the thing that sucks up the most power. But yeah, this is a EVGA 600 watt one. Probably the minimum you want to go nowadays, 650. Here's a 650 one. Here's a 1000 watt one, and basically it's just how much power various components suck up. So the TDP, or the expected power draw, is another important factor of CPUs and GPUs. So effectively, you can't just like, oh, here's the strongest CPU, $8,000, let's put it in my computer. Here's the greatest GPU, whatever the price is at the moment, put it in, and then expect it to work even if your motherboard is compatible at like a 700 watt power supply. It's just not going to work. So effectively, that's why bigger power supplies exist, is because they're needed for more expensive graphics cards and CPUs and stuff. Things generate more power. Now, just because it's more expensive doesn't necessarily mean it's going to generate more power. Most of the time it does. Sometimes improvements will be lowering the power, but typically CPUs eat up anywhere from like 40 watts to like 150 watts or something, depending on the strength. In desktops, laptops, they typically are cranked much lower to like 10, 15, 20 watts because, you know, they don't have as much, right? This is a big 1000 watt. The other one was a 96 watt. Power supplies also have kind of like ratings, effectively. It's not that important. Higher ratings, gold, platinum, are better, typically better warranty, better parts, components. Bronze is typically the lowest. One typically, again, has stuff to do with warranty, how well it sustains loads over time, that kind of stuff. So yeah, I'd say 650 is a good metric at this point for power supplies at the moment. CPU types, there's a lot. Effectively, there's two companies that make CPUs, Intel and AMD. Intel, as you know, has stuff like the i5, the i7. AMD has stuff like the Ryzen 3, Ryzen 5, Ryzen 7, Ryzen 9. Those are the two companies. They have CPUs. They run at different gigahertz, base clock. There's turbos. I already talked about the nanometers. Effectively, all you need to know, smaller nanometer, better thing. Intel's stuck at 14 nanometers. No amount of adding plus to it's going to fix that. AMD has 7 nanometer stuff, which means buy AMD until you hear otherwise from reviews. Yeah, CPU types, gigahertz are effectively how many times a second that thing is happening. So you might expect, oh, base clocks are higher base clock of like 3.8 is better than 3.2. Well, no, it depends on efficiency and all that stuff. And it also depends on how it's cooled. There's factors. But effectively, if you're looking for a CPU, you're most likely, if you're watching this video, which no one is, but if you're watching this video, you're probably buying a laptop. And so the gigahertz don't really matter because you can't change it or boost it or do anything to it anyways, so just don't really worry about it. A great example of that is Apple when they had their 2.3 gigahertz i5s or whatever, and then they changed to a 1.9 gigahertz. And people are like, oh, it's a downgrade. And it's like, well, actually, no, it's more efficient now, so it's actually an upgrade. Even though it might look worse to have a less many times a second running thing, it actually is better because it was more efficient. It didn't suck as much power. It means battery life improved and all that stuff, right? There's trade-offs to everything. But yeah, that's effectively what that means. Turbo, you can improve your base clock on desktops. So if you don't like the way your processor is running, you can boost it up. Let's say Ryzen has a boost of Ryzen normal's 3.0, you could boost it to like 3.5 or something if you really wanted to. Obviously that increases your power draw and stuff, but it's just something to keep in mind. Core count, typically on top of the nanometers, core counts increase. 8 cores are what you want to shoot for at this point. For a while there, we were stuck at hexacore and 4-core because of Intel. Now the AMD is kind of bulldozed through that. 8-core, 10-core chips are becoming pretty normal. One thing, obviously, that you want to keep in mind with your CPU is temperatures, how hot the thing is getting, and throttling, which is effectively, once it gets to a certain point, kind of shuts down and so it lowers its throttling temperature. A good temperature for CPUs to be at is obviously under 100 degrees. These are measured in Celsius, but definitely under like 90. So you want to sit in that like 70 to 80 range is a good range to sit at, generally when you're doing stuff, as to not get too hot. Heated CPUs for a long period of time obviously hurt the longevity of it. GPU types, graphics cards, let's just go through that real quick. NVIDIA, big player in the graphics card space. AMD, the player that has CPUs, also has graphics cards. Graphics cards are mainly used for games and for intensive workloads like rendering movies and crap. So this is, this one. So plug that in. As we said before, render out movies, render out animations, games, that kind of thing. The GPU's main goal is to do one thing really good constantly, many, many times over. And that thing is render out images really quickly. And that results in high frames in your games and good renders and quality and that kind of stuff. And that's effectively what they're useful for. Games, simulations of some sort, could be CAD, 3D modeling of objects, rendering out movies and stuff, math simulations, doing calculations. That's what crypto is based off of. And that's what GPUs are. Many different types of GPUs, not that important. All you need to know is you're not going to be buying one anytime soon because the pricing on them is absurd because of all the COVID stuff. So, yeah, not need to worry about that. But basically, it's your big horsepower, runs a lot of stuff, is really good. A good one at this point is the RTX 3060, which was supposed to be about $400 until it's $2,000 now because people are insane. So USB definitions, that's a whole lot of hell that I don't want to go through. Effectively, you have many types of USBs, and they, as we said, USB AC, all that stuff from before. But they all have their different types, similar to how I said HDMI 2.0 and 2.1, how they're different. The display port is different, all that stuff have different versions that effectively allow for different things. That's effectively what USB has. The simplest explanation I can give for USB things is a look between USB 2 and 3, because past that, no one gives a crap. USB 2, white inside connector, slow, painful. USB 3, blue inside connector, speedy, great. 3.1, weird. You might sometimes hear USB Type-C, which is the good connector that has the power and the external display and all that stuff. You might hear that listed as USB 4. That's because USB-C is not all-encompassing. There's different varieties of USB-C. Thunderbolt is Intel's version. Effectively, USB-C Thunderbolt means it can do things like those external displays and that graphics card and all that stuff, versus normal USB-C can just do charging, power, right? So if you have a normal USB-C input on like a desktop or on a laptop, it's just pure charging. If you have a Thunderbolt one, it says Thunderbolt 3, 4, anything like that, then you're automatically allowed to connect an external display to it, connect power, external power and stuff to it. So yeah, that's effectively there. I'm not going to go through the definitions. There's like 3.1, 3.2, 3.2, Gen 2, 3.24 by 2x2, whatever. Not important. I somehow managed to get this far into the video without talking about the main OS. Are we still going? Yeah, we're still going. So yeah, I managed to get this way into the video without talking about that. Just making sure we're good. Yeah, we're fine. Okay, so next thing is I want to talk about 3 OSs. So all this time you might be building your computer as I'm talking, obviously, or learning about the different USB types and the modes and stuff like that. And you may be wondering, okay, I have my questionably built computer. What do I do with that? And the first thing you want to do is, if you build it yourself or any of that, you want to know about the OS it's running at. So there's 3 types of OS. There's Windows, Mac, Linux, and screwed up versions of Linux. So what that means is Windows, obviously by Microsoft, that's typically what you're most familiar with. Windows is the operating system that everything runs on. It's what I'm running at. It has, the typical things. You know that. Windows is x86, as we talked about architectures beforehand. That's what Windows is, x86, which is, good. Mac is also x86. Everything's x86. It's just dependent, right? Most things on Windows are running x86 architecture. There are some things, as I said, that Microsoft one that is running, like the ARM one, right here. This thing is running Windows, but like ARM Windows. It's running a different version of Windows. So the base Windows is called Windows 10 Home or Windows 10 Pro, doesn't really matter. It's, you know, the normal version of Windows. It's this thing, right? It's running all the Windows stuff. Windows 10 for ARM is a little bit different, and it's running a little bit different things because it's a different architecture, right? It can't run normal x86 stuff. So Windows is there, owned by Microsoft, operated by Microsoft. Benefits include freedom, lots of crashing and forced updates, and whole lots of fun. And we have Mac OS, which is owned by Apple. And Mac OS is lighter weight typically, doesn't have as much stuff going on. It's simpler and easier to use. It's more restricted in some ways. They have a lot of custom things like AirDrop and stuff. Typically Apple apps run better, optimization is better, because one thing that's important to know is Windows is a big system. It runs on everything. When I said there's 4 types of computers, I meant there's 4 types of computers. Things that run on Windows 10 shouldn't really be qualified as computers. There's like the restaurant POS system that runs off Windows 10. The billboards you see typically also run off Windows 10. It's being used for what it's built for, which is nice. Not to say Windows is bad or anything. It's just it's being used for a lot of stuff. So yeah, those. Oh, and then Linux. So this video is already almost an hour long, and it'd be real fun if I just upload the entire thing like this. Which, you know what? I'll do it. That sounds fun. Yeah. So the other type of OS is Linux. Linux is an open source OS, and it's effectively the 3rd version of main computer operating systems. There's obviously iOS and Android and that kind of stuff. But Linux is what's called open source, effectively meaning I could go to Linux distro right now, download it onto my computer, upload it to a little flash drive, plug it into a different computer, install it anywhere, and it would work perfectly fine. It's open source, just means anyone can download it and add code to it. That's effectively what a distro is, a distribution in computer science, or I guess coding terms. Effectively the base version of, so Windows 10 is a base version of Windows 10, right? Windows 10 Home is a base Microsoft stock version. Same thing with Mac OS. Linux doesn't really have a base version. It has recommended versions, but the main benefit of Linux is there's multiple versions of it. You don't like Mojave or whatever this is, Manjaro I think actually, you can change it. So you don't like, so Linux is really a customizable version effectively of an operating system, and it runs off a little bit of different principles. So there's many distributions, as I've said, and they all have different things that they can do, different ways of showing things. So for instance, Windows, if you're familiar, Mac OS, you know, it has the bar at the bottom, you go, your Finder, it has, you know, a browser, you download apps, you can download through the internet by just clicking a download button, you have your App Store. Windows, you have your, you know, your start menu. You can download it through the Windows Store or through online, that kind of thing. This is kind of set up. You can drag and drop stuff, that kind of thing. Linux is a lot more different. So depending on the interface you go with, there's a lot more technical stuff needed typically to run Linux. Now, it's not a hard operating system to learn by any means, and there's certain Easy Pop is a good one for beginners. Manjaro, this one's a little bit more complicated, or Mint, I'm not really sure what this is, but yeah, effectively things are done through command lines, right? And they're effectively terminals and command lines, sort of the underlying functions of an operating system that Windows and Mac OS try to alleviate you from having to use. Linux can sometimes get into that territory. That's not bad, it gives you more flexibility, but it's something to keep in mind. So you have your, you know, your calendar and your different stuff. Like, you know, you still have your programs, but a lot of things are a little bit different, right? It's not a new architecture. I think it's still based on x86, I'm pretty sure, in a lot of cases, but it's just a different way of installing things. Easy Pop, for instance, has its own pop store that you can download stuff through. Other things like this, not necessarily. So keep that in mind. It's effectively just a more wide open version. It's free, obviously. Mac OS technically isn't free. Windows technically isn't free. Like if you make a PC or build a PC, you have to buy a Windows license. Same thing with Mac OS. Buy a computer, it gives you a license, but it's not a free thing. Linux is a free thing. It's open source. So yeah, last couple things. The laptop categories. So we haven't really talked about laptops. I typically use a desktop. I do have a MacBook Pro. Again, many people coming to the video are going to look at sort of the laptop definition. So laptops are important and they're useful, and so here are the categories. We have 4 types of categories that this can really go to. So we have, we have a couple of different versions of those. We have the normal, so there's, 4 different laptops. There's normal laptops, ultrabooks, gaming laptops, and workstation laptops. So normal laptops are just the laptops you would typically buy, typically use, that kind of stuff, consumer grade laptops. Ultrabooks are super thin, productivity focused machines that are typically more expensive but are meant for portability and sort of usability. So for instance, the HP Envy Firefly, whatever this is, you have the Dell XPS 13, you have the Razer Blade Stealth, you have the MacBook Air, you have the Microsoft Surface 4 laptop, and then the Asus ZenBook. This is not a ZenBook, but this is like what comes up when you type Ultrabook. So yeah, that's that. And effectively they're thin, as you can see, they're light. They usually don't have a graphics card, so as we were talking about before, where things need graphics card, CPU, they don't need a graphics card. They can have what's called integrated graphics, effectively graphics cards that are integrated into the CPU. They're kind of like little sections of the CPU. A lot of laptops, even if they have graphics cards, don't have full-blown. They have laptop versions of graphics cards. So yeah, they're thin, they're light, they have a CPU, they have a mini GPU, and they typically benefits are they're thin, they're movable, usable. People like them, which is interesting because if you look at a normal laptop that's not necessarily trying to be an Ultrabook, then you might see, oh, it has better battery life and a more industrial design, but it's mainly a design thing that you would choose. An Ultrabook usually they have better quality and materials and stuff. And then you have gaming laptops, which are just beefier versions of normal laptops. A good example is like the Alienware M15. I don't know if that's still a laptop. It probably is. Bigger laptops. Yeah, here it is. So thicker laptops, bigger laptops typically have either laptop version graphics cards or sometimes even full-blown graphics cards, laptop versions, but still like much better than what you could normally get, and they're typically focused on gaming on a laptop screen. And then finally you have workstations, which are kind of a dying breed at this point because most people that want a workstation laptop just kind of use a desktop or some other type of virtual thing. But workstation laptops are beefier, I would say productivity focused ones. So this right here is the Asus ProArt StudioBook, whatever, workstation laptop. They're typically like $3,000 for some reason, and they're mainly focused on creation. So for instance, this has no OLED screen. I don't have time to get into the difference between screens. That's not really important, but you have the big screen that's used for things like photo editing, video editing, animation, color correction, photography, that kind of thing. And that's basically what it's used for, right? It's used as this big, I'm business doing business things laptop there. $3,000 are people that can't carry around a big desktop or don't want to stay in one place. They need something like this, and so that's for them. Typically has a lot of ports, typically is very high quality. This one, for instance, has a lot more RAM. This has 48 gigabytes of RAM and a 2 terabyte SSD. We already talked about what that means. And typically their graphics cards are, yeah, I'm good. What is it? Oh, it's a coupon, $1,400. 1,400. So I just said these are supposed to be about $3,000, which they're supposed to be. That's a 9th gen Intel, 48 gigs of RAM, 2 terabytes of that, Quadro, which is effectively NVIDIA's like business version, and that, right? And this should be, what does this coupon say? It's supposed to be $2,800, which is cheap. Apparently it's $1,400. There's no way it's $1,400. This is like a $3,000 machine. Prices are weird. If you can somehow get this for that amount of money, you're cheating. Anyways, so yeah, that's effectively what that is. So laptops, as I said before, can't really be upgraded. Those are the 4 sort of laptops and what their use cases are. I already talked about integrated graphics, obviously upgradability. Batteries. Batteries have cycles. Every battery typically at this point is made with lithium ion, which means it's chargy boys, and they charge, and eventually after 100 charge cycles or whatever, they drop in percentage. So if you're familiar with the battery health thing that Apple and Google have been promoting, it's effectively a way to see your battery health from when it was new to now and figure out how long it's been since, how much your battery is effectively degrade, right? Because all batteries degrade after 100 charge cycles. I think it's like 80%, 200, I'm not sure the exact number, but it's like 80% capacity from when it was originally new to now, and that's effectively your charge cycle, right? A full charge cycle is 0 to 100 or however many it is. The more you keep doing that, the weaker the batteries become. I decided I already talked about Ethernet, I already talked about VGA, DisplayPort, main DisplayPort. Finally, we're done. The last thing I need to talk about is Wi-Fi. So Wi-Fi, as I said, for Wi-Fi cards, there's a bunch of different versions of Wi-Fi generations, if you will. Typing is weird. Okay, so there's all these numbers and stuff. I know what these mean now because I'm taking IT major, but basically there's Wi-Fi 4, and no one uses Wi-Fi 4, it sucks. Wi-Fi 5 is typically what a lot of things are. It has a 802.11 AC. That's effectively just a standard of Wi-Fi 5, and it says for things like the speeds of Wi-Fi, the latency of Wi-Fi, that kind of stuff. Wi-Fi 6, a lot of things are Wi-Fi 6. My computer does not. It's old. 2017, Wi-Fi 6 hadn't been invented yet, or certified, whatever, yet. A lot of newer devices have Wi-Fi 6. I believe the PS5 has Wi-Fi 6. The Xbox Series X I'm not so sure about. But yeah, Wi-Fi 6 is effectively a better version of Wi-Fi. And a couple things so better version of Wi-Fi, right? It's obviously better. And that also means in order to get Wi-Fi 6, you have to have 2 things. The capability in your area via your ISP to get Wi-Fi 6, and the router to be able to transmit that Wi-Fi 6 from wherever you get it to your area into your devices via that Wi-Fi thing. And your Wi-Fi, so like typically the ISP giving you Wi-Fi 6 speeds or capability is dependent on your router because they're usually in tandem, not necessarily always. If you buy your router separately and your router doesn't support Wi-Fi 6, but you can get Wi-Fi 6 in your area, then you upgrade your router, and then it's your device. So every device needs to be able to access Wi-Fi 6. Modern iPhones and Android phones, whatever, have it. Does the iPhone XR have Wi-Fi 6? I think I looked this up at some point. That's useless. So the 10R does not have Wi-Fi 6. The 11 has Wi-Fi 6. So that's important to know. So this does not have Wi-Fi 6. The iPhone 10R, the iPhone 11, starting from the 11, 12, 13, has Wi-Fi 6, which is better Wi-Fi, but it doesn't matter if your ISP can't deliver it to you. So that's effectively Wi-Fi 6. That's the generations of Wi-Fi. And there's 2 more things. There's 2 types. So on top of Wi-Fi 6, there's generationless speed. There's also 2 different waves, 2 gigahertz and 5 gigahertz. 2 gigahertz, kind of the difference between 4G and 5G. 2 gigahertz is very wide but slower. 5 gigahertz is very condensed and shorter, right? Shorter distance but much faster. A lot of modern routers, like we have Google Wi-Fi. It doesn't look like this thing. It looks like the old, this thing. This one right here. A lot of these automatically switch between the 2 no matter what. So they won't say, oh, do you want to connect to the 2.4 gigahertz or the 5 gigahertz? They'll just change depending on whatever's best for you. Some older devices and now some older Netgears do not. You have to choose which one you want on it. That's important to note. With that, this is actually qualified as a mesh router, which we'll talk about now. But yeah, 2 gigahertz, large, wide band, typically slower. 5 gigahertz, smaller radius of where it can be accessed from, but it's quicker. Mesh networks are effectively, so if I have 3 of these, so we actually have a mesh network. Basically, instead of having to have like your router connected to your modem in one part of the house, and then if it doesn't reach to the other part of the house or it gets blocked by walls, having to put up an extension of that and connect to that separately, having separate things. A mesh network effectively connects all of them to one thing. So we have 3 or 4, I think, mesh pods right here that we hook up around the house, and when we connect to our Google Wi-Fi, it's a single Wi-Fi connection. It's not like our old Netgear where it was 2.4 and 5, and then you had the extension that you could connect to. It's just one thing. So that's effectively what a mesh network is. Okay, that's, I think, everything I wanted to cover, just to make sure I talked about the types of computers, the architectures, desktop versus laptop, what desktop's used for, a bunch of talk about I/O, components of computers, the PCI Express and the types of them, what they do, CPU, GPU, what heatsink and thermals are, what types of memory and storage you got, the power supplies, CPU types, GPU types, USB definitions, the main OS types, laptop categories, sizes and what they're useful for, the batteries and chargers, the Wi-Fi generations, what they mean the mesh networks, Ethernet, some other I/O, and then finally the shortage and how it affects us. It sucks. Things are more expensive. Okay, if you enjoyed this video and want to see more of this kind of stuff on the channel, please don't, because it took too long, and I will see everyone in the next video.